Welcome. In this lecture, we are going to be making some tweaks to the way we call raycasting so that we only hit the backboard, and we're also going to be looking at how we can clear up all these projectiles so that we don't end up slowing down our game, which might be a problem that some of you have noticed. So let's dive right in. So here is the game as we left it in the last lecture. Now there's one thing that you may or may not have noticed in just playing around with it, is that as we fire more and more of these balls, things start to get a little bit laggy, and it's starting to get noticeable on my system now. Now the reason for that is that the balls are not getting cleared up. So if I stop play, which took a little while because of that problem in fact, what we can do is use a script that I've already put together for us, physics assets. Under the projectile, there is a projectile expiry.cs script, and basically all this will do is delete the projectiles after a fixed amount of time. So if we drag this onto our projectile prefab and then look at our projectile prefab and scroll down, you'll see that the expiry time is 10 seconds. I'm going to knock that down to about 5, save and hit play. So now it shouldn't matter how many projectiles we create. If we're looking at our hierarchy, we should see that at a certain point, there you go, the list of projectiles isn't getting any longer, and as I stop firing them, the projectiles slowly all go back to disappearing. And if we look down, we'll notice that there are no projectiles down there anymore. Perfect. So we're going a little bit faster now, and we're not slowing down the program, not slowing down the game as we play for longer. Now let's have a look at our hoop. You'll notice that when we're looking at the hoop, it sort of judders as the hoop goes by, and the reason for that is that the raycast is hitting the hoop as well as this backboard. So we need to figure out a way of making sure that the raycast can only hit the backboard. So if we go ahead and open up our script, our aiming ballistic script, and we'll say yes to all here, you will notice that this raycast has an opportunity to have more parameters, and we can be more explicit with what we give it. So let's have a look at the Unity documentation. You'll notice here that there are a few different types of parameter, and we have the option to add in a max distance. So that is how far the ray will travel before giving up and saying that there is no hit. There's a layer mask, and there is a query trigger interaction. So if we click on query trigger interaction, it's basically saying either use the default settings or ignore triggers or collide with triggers. That's fairly straightforward and fairly obvious what that's doing. What about this layer mask? So let's search down into where it explains the parameters a little bit better. And here it's saying it's a layer mask that selectively ignores colliders when raycasting. So you should have a look at this documentation and see if you can pass these parameters into the raycast and create a new layer that allows us to ignore everything but this backboard. In fact, let's call this cube the backboard. There you go. Now I've renamed that, and it should be fairly obvious what I'm talking about. So let's have a look. So ignore all but the hitboard, or hitboard or backboard as we call it. Use the documentation to guide you. So that's the documentation on this page, and there will be a link to that in the resources for you to follow. And I'd like you to create your custom layer mask. You'll need to revise how to create your own layers and custom layers first. And then you can you pass it in to the raycast call. So you'll be able to find details on how to do this in the documentation. Just have a little go at reading through the documentation, getting used to how that works. Does it behave as you expected? Give it a little test. Okay, pause the video and have a go at this. Welcome back. So we're going to have a little look. So the first thing we need to do is pass in a parameter for max distance, because if we want to pass in the layer mask, that max distance needs to be done first. So we'll go to our ballistic aim component, and we are going to have a max distance here. Now, all we want to do is that default value of infinity, and you can see that in the documentation here. Max distance equals math infinity. That's how you would have got that clue. Next up, we want to set the layer mask. Now, how do we set the layer mask? Now, unfortunately, Visual Studios is not really prompting us with the correct things here. So we're going to have to do it from the documentation instead. So let's have a look at the layer mask. Basically, the way we have to use a layer mask is written here. You create a layer mask is 1 shifted by the number of the layer. Now, basically, you don't need to know too much what's going on here, but a layer mask is using the bits in an integer to define which layers are active and inactive. So what we'd do is 1 shifted by 8, and we'd use that with our 8th layer. So let's create a new layer. We go to layers, edit layers, and then you'll notice we've got user layer 8, which is the first user layer, and we're going to call this the backboard layer. And then we've got to go to the backboard, assign that to that layer. So in the inspector, we go to layer and then backboard. Just quick revision of stuff we've already done with layers. And now this parameter should enable us to only raycast on those particular layers. So let's hit play and check out whether we are getting the desired behavior. There you go. With the ring now passing by, we are not jolting around with our cannon. However, it's also simply not working with the backboard. Now, the reason for that is that we changed the cube layer while we were still playing. So let's go to the layer. I have to add that layer in again. And let's call it the hitboard, like I called it in the slide. And call the cube the hitboard as well. And assign it to the correct layer. So done it twice there. So you definitely should be able to remember it this time. Now let's hit play. There we go. Now the cannon is moving, and as we look at our ring, it is not getting affected by raycasting with that ring anymore, which is exactly the behavior we wanted. When you are comfortable with those layer masks and using layer masks in raycast calls, move on to the questions where we will just test that knowledge. See you there.